Welcome again in Automotive Spice in Practice. Today we will talk about engineering processes of automotive spice, popularly called the development or left side of the V model. We'll go through all of the processes starting from the system group to the software process group and check what are the traceabilities in between them. Since requirement solicitation process SIS1 is not part of the video scope, today we will skip this process. We will talk about system requirement analysis. We will talk about system architectural design, software requirements analysis, software architectural design, and of course, software detail design and unit construction. We will go through each base practice of these processes and talk about their interconnections. For today's lecture, the main focus is to learn how we can develop the code starting from the system requirements analysis. Let's now try to map system requirement analysis to ISO 26262 and information security standard. For sure, in the Automotive Spice framework, this is mandatory process and part of VDA. We are mapping it to the ISO 26262 in the way that we are finding some similarities to functional safety concept, the specification of the technical safety requirements, and specification and management of safety requirements. In the information security standard, we can find the similarities in security requirements of the information system and also in security in development and supporting processes. It means that without having very good established maturity model of the processes like it is automotive spice, you cannot really reach any kind of standards like ISO 26262 or information security. Let's now check what is the purpose of the system requirement analysis process. Here it is written that the purpose of the system requirements analysis process is to transform the defined stakeholder requirements into a set of system requirements that will guide the design of the system. This is true. It means that we need to have established a good system requirement analysis process in our company if we want to use the customer requirements. Now let's check what are the outcomes of this process. There are a lot of outcomes of this process. I think even 8 of them. The first requirement or outcome of this process is that you need to have system requirement established. You need to define a set of system requirements and you need to have those requirements in the written form. Then you need to have categorization of them. It means that all the requirements that you received and then transferred to your system and then established in the written form, you need to have some kind of categorization and you need to have according to the analysis, what are the correctness and how you will verify those categories of the requirements. In the next outcome, we have impact on the operational environment. It means that the impact of system requirements on the operating environment is analyzed. We need to have in the written form what is the impact of an operational environment. Then we have one outcome, which is talking about prioritization of implementing the system requirement. It means that you need to define what are the requirements which needs to be developed firstly, and then what are the succeeding requirements on the system level. Then we have the system requirements update, which means that you need to regularly maintain the update of the system requirements if necessary. This is for sure something which will impact all the levels down. Now we have the outcome, which is zooming the consistency and bidirectional traceability. It means that you need to establish the bidirectional traceability and consistency in between stakeholder requirements and system requirements. And you need to have also the bidirectional traceability with system architecture and of course system requirements. Then you need to have really the bidirectional traceability with system requirements and software requirements, which we will mention later on. Also, we need to evaluate the system requirements for cost, schedule, and technical impact. And of course, we need to agree and communicate that the system requirements, as they are written in our documentation, in our technical documentation, are something which is really desired by our customer. System requirement analysis means that we want to transfer customer requirements into the system requirements. For that, we will need some kind of inputs like management process, like customer requirements and SIS1. Here on this diagram, you can see that system requirement analysis has 8 base practices. 8 base practices are basically explaining how we can transform the customer requirements into the written form of the system requirements, which will be used for sure later on for the development. In this gray block, you will see that some basic steps are written. We need to specify system requirements by using customer inputs. Then we need to structure and analyze them and have some kind of verification criteria for later on for testing. System requirements needs to be traced to the customer requirements in the system architecture. Then we need to have the reviews, formal reviews for system requirements. All the formally reviewed system requirements must be communicated to all relevant parties. This story is reflected through 8 base practices here, and the intention of this diagram is basically to summarize what are the next steps when you're performing system requirements analysis. First step or first base practice should be that you need to specify system requirements in the written form. Then you need to structure them, you need to analyze them in the overall, and you need to analyze specifically the impact on the operating environment. Then you have 3 base practices which are talking about some kind of verification. First type of verification is that you need to have developed verification criteria for testing. Then you need to have established bidirectional traceability, as already mentioned, to the customer requirements and system architecture. You need to have consistency, and the consistency means that you need to ensure that the reviews are done, that everything that you developed or write in the system requirement specification is checked by your peer. Then in the BB8, we have this communication to all relevant parties. The output of this process is basically system requirement document or system requirement specification, however we want to call it. Then this includes categorization, analysis, prioritization, verification criteria, and of course traceability. One of the outputs is also system requirements review. From system requirements analysis, we can now develop the system architectural design. And this is the next automotive SPICE process. It is also a mandatory process and part of the VDA scope. And mapping to the ISO 26262 is shown through the system design. Mapping to the information security is shown through the network security management and information transfer. The purpose of the system architectural design process is to establish a system architectural design and identify which system requirements are to be allocated to which elements of the system, and to evaluate the system architectural design against defined criteria. This is the definition of automotive spice. But additionally, there are some outcomes which are zooming this definition. Well, you need to have system design defined. It means that you need to have some written form of architectural design, and that this design is basically including all the elements of the system. Then the next outcome is system requirements allocation. It means that the system requirements are allocated to the elements of the system. For that, we need as well system architectural design document. Next outcome is telling us that interfaces, all interfaces must be defined. It means that we need for that some chapter in the system architectural design that is specifying all the interfaces. We need to specify as well in the system architectural design the dynamic behavior of the system elements. Of course, system architectural design must be bidirectionally traceable and consistent with the upper level and the level of the next decomposition of the requirements on the software level. It means that you need to have bidirectional traces to the system requirements analysis. You need to have the bidirectional traces to the software requirements analysis. And of course, you need to have the bidirectional traceability with the verification side of the V. And about that, we will talk about in the next lecture. On the end, we have the outcome that all the system requirements, architectural elements must be agreed and communicated to the affected parties. The whole process is described in 8 base practices. For the input to this process, we are assuming that it is enough that you have the system requirements analysis and that you have management process. In the base practice 1, you need to have development of the system architectural design in the written form. Then, as outcome said, you need to have allocated system requirements. You need to have defined interfaces. You need to have dynamic behavior. You need to evaluate system architecture, and you need to have some alternative and possible system architecture and to choose between those alternatives. Also, you need to have established bidirectional traceability and consistency, and on the end, you have to communicate what is agreed and what will be the system design. This process is used as creation and evaluation of system architectural design and for allocating the system requirements. You can see that the outputs are system architecture, which includes system elements, requirements allocation, system interfaces, dynamic behavior, resources, consumptions, and traceability. This was the explanation of the system group processes. And now we are going to explain what are the software requirements analysis. And this is also mandatory process, part of the VDA. How we will map it with the ISO 26262? Well, in the ISO 26262, there is a part which is explaining specification of software safety requirements. And also, this is a mandatory process in ISO 26262. It is part of the chapter 6. Unfortunately, in information security, there is no such a mapping. The purpose of this process is to transform the software relevant parts of the system requirements into the software requirements in the written form. It means that we have the outcomes which are talking about specifying specifically only the software requirements, and that we need to allocate software requirements. This is the first outcome. And this must be done in the written form in some kind of the software requirement specification. In the next outcome, we need to categorize and analyze software requirements. It means that you need to have in software requirement specification some specific part where you are talking about how you're categorizing and analyzing for the correctness and verifiability software requirements. In the outcome 3, you need to perform impact analysis. And the impact analysis of the software requirements are on the operating environment, and they need to be really in the written form, also in software requirement specification. Then we have the prioritization, and we need to ensure that we are doing always the update according to the updated system requirements if necessary. Of course, software requirements should be bidirectionally traceable to the upper levels and to the software architectural design, as well as verification side of the V. After doing the consistency and bidirectional traceability, we need to always evaluate the software requirements for cost, schedule, and technical impact. And after finishing all the steps which are written here, we need to communicate them to the all affected parties. It means that all the affected parties must be agreed with our specification. Now let's see what are the best practices of the necessary outcomes. We already said that this process is meant to be used for transformation of the system requirements into the software requirements, and that system requirements analysis has a very big impact to this process. It means that this is the main input to our process. Also, the system architecture is one of the inputs to our process. This process is explained through 8, let's say, steps in the form of best practices. And they are specify software requirements, then structure software requirements, analyze software requirements, analyze environment, find what is verification criteria and write it, and then trace and check consistency. After you finish all the steps, you should communicate your software requirements to all affected parties. The outputs of this process are software requirements, which includes all the things like categorization, analyzing, prioritization, verification criteria, and traceability, and of course, software requirements review. Next process is software architectural design. This is also a mandatory process and part of the VDA scope. It is mapped to the ISO 26262, Chapter 7, Software Architectural Design. It is also a mandatory process in the ISO 26262. In the information security, there is no such a mapping. The purpose of the software architectural design process is to establish an architectural design and to identify which software requirements are to be allocated to which elements of the software, and to evaluate the software architectural design against defined criteria. Let's now check what are the outcomes. The first outcome is that you need to have software architectural design in the written form. It means that you need to have software architectural design document. Then you need to allocate software requirements to the elements of the software. This is also part of the software architectural design. You need to specify the interfaces and to define them in the way that you have the written format of them in the software architectural design document. Then you need to check the dynamic behavior and resource consumption. and this is also part of the software architectural design document. Of course, as all other processes, software architectural design process needs to be consistent and bidirectional traceable. It needs to be traceable to the upper levels. It means to the software architectural, to the software requirements analysis. And of course, to the down level, it means that it should be traced bidirectionally to the software units and code construction. Also, there should be the link in between the software architectural design process and the right side of the verification in the V model. On the end, we have the base practice, which is talking about the outcome, which is talking about communication, and that the software architectural design must be agreed and communicated to all affected parties. Now, let's see how those outcomes are zoomed in the best practices. For this process, we need the inputs of software requirements process. This process is meant to be used for the creation and evaluation of the software architectural design and for allocation of the software requirements. It means that software requirements are used to develop software architectural design decomposed with software elements. Software requirements are allocated to the software elements. Then interfaces between software elements are defined, and dynamic behavior between software elements is described. Also, the resource consumption objectives are defined, and alternative software architectures are evaluated. Software architecture is traced to the software requirements, and software architecture is, of course, reviewed. The software architecture must be communicated to relevant parties, and all these steps are basically referring to the 9 base practices. The outputs of this process are software architecture in the written form with all the elements like software elements, requirements allocation, software interfaces, dynamic behavior, resource consumption, and traceability, and of course, software architectural review. The last process on the left side of V is software detail design and unit construction. This process is also, of course, mandatory process and part of the VDA scope. It is also defined in ISO 26262 like software unit design and implementation in Chapter 8. It is also mandatory process in ISO 26262. In information security, there is no mapping to this process. The purpose of the software detail design and unit construction process is to provide an evaluated detailed design for the software components and to specify and to produce the software units. It means that this is the process where we are describing our algorithm and how we are doing the coding. The outcomes are that you need to have software detailed design, which is describing how you will produce your software units. It means that you need to have some written form of such a design. Then you need to have included interfaces and description of them in the software detailed design. Of course, dynamic behavior must be added to the software detail design and must be explained in some separate chapter. Then we have the consistency and bidirectional traceability. There are a lot of traces which needs to be there. First one is, of course, that you need to have the software requirements and software units traceable. Then you need to have software architecture and software detail design traceable. Then that you need to have software detail design and of course code traced. And on the other side of it, you need to have the traceability in between software detail design and software unit verification. Then we have outcome, which is talking about communication. The software detail design and the relationships to the software architecture design must be agreed and communicated to all affected parties, almost similar or in the same way as we done it in the previous processes. For that, we need communication record, which could be also some issue tracking or minutes of meeting. Then, on the end, we have the final outcome, which is talking about producing the software units, the really exact coding of the software units. This process includes 8 base practices. Inputs for this process are software requirements and software architecture. This process means that we need to design software components and implementation of the software units code. Then, through these best practices, we can read that software requirements and software architecture are used to design each software component to decompose in software units, if necessary, of course. This process is done for each software component. Software detail design must be evaluated. It must include interfaces and it must include dynamic behavior description. Also, software detail design must be traceable, as we already mentioned, in all kinds of directions. The software detail design specification or some kind of document must be reviewed, and this is basically related to the BP6 consistency. Software units must be developed in the way that they are really compliant with the software detail design. All those steps are, as I said, part of the 8 base practices. The outputs of this process are software detail design with all the interfaces, dynamic behavior, traceability, then the code, and of course, software detail design reviews. In order to prepare for the next exercise, which I will give you in the live session, you should try to read through the ASPICE 3.1 supplement and to discover what are the minimum processes to be changed if we change something in the system requirements analysis process.